Good morning children, good morning students, and welcome back to the session. Okay, so far in the videos we discussed how to write the functions, how to invoke the functions. Have you ever thought you could call the function by itself? Yes, you can, and the technique is called recursion. It's a very important program in programming world. There are a lot of applications of very complex algorithms can be written using recursion. Recursion, by definition, it goes this way. It refers to a programming technique in which a function calls itself either directly or indirectly. So this definition says recursion are of two types. One is direct and one more is indirect. Okay, before discussing what is direct and indirect, I'll show you a picture which I found in internet. This matches very close to the definitions of this recursion. That is a picture of a painter who is painting a picture of a painter who is painting a picture. It looks complex, but no. When you master, I'm sure when you master this recursion technique, you are going to replace all your loop statements, whichever you used while and for. You're going to replace this with a recursion only. Yes, let's get inside. Now, I told you there are two types of recursion. That is, one is direct recursion and indirect. The picture itself says when a function calls itself directly, it's called direct recursion. Whereas when a function calls other function, wherein the function inside this function calls the caller function, it's called indirect recursion. So by end of this video, you will now start writing the two different ways of techniques. Okay, these are two techniques. I'll give you, like in while and statements where we ended with the infinite loop. Yes, similarly in recursion also there is one scenario. Just look at this piece of code. It's called, look at this piece of code. This piece of code, something like infinite while loop only. Your Python gives you an runtime error. The error message is called maximum recursion depth exceeded. See, look carefully. Your function 2 calls us, after this is invoked, it comes over here. Yes, again this function 1 invokes this. Yes, endlessly these two statements are going to be printed. Correct? There is no point wherein it stops invoking itself. Continuously it is going to invoke itself indirectly this way. Yes, so this is a runtime error scenario. To avoid this, there is one thing important called the base case. That is a case which stops calling the function by itself. There should be a check. That's very, very important while writing a recursion program. So two requirement that fulfills sensible recursive code. Why I'm telling this is not a sensible. See, the problem with this code is it is a recursive program, but the recursion code is not sensible. You must write a sensible recursive code that has clearly defined where to stop. Okay, these 2 points are very important when you're writing recursive program. First is, it must have a case whose result is known or computed without any recursive calling the base case. Okay, that's called the base case. Second, it should have a recursive case whereby function calls itself. While reading it will be little confusing, but I'm showing you how your computer is going to handle whenever the function is invoked. You will very much understand the 2 points. Let's discuss that. Okay, I have taken a simple example. We already wrote this program using for loop and while loop. That is to compute a function to compute the sum of numbers from 1 to n. N we are going to enter from the keyboard using recursive function. Okay, the function is very simple. This is a base case which we are discussing in the last slide. That is the condition. I have to stop calling this compute function at one point of time. That is, when my number reaches to 1, I'm going to return 1 and stop. Else I'm going to do this 4 plus pass 3. yes, and goes on until 1, and there it stops and it give you the result. Now let's see how your computer is going to handle each step. Okay, how does the computer is going to handle how does this recursion work? Very important. First, in executing a program, first step, the computer creates what is called function stack, kind of like a bucket. It creates a stack. Okay. Second, the function stack is a stack of frames. You'll get like a ladder, lot of frames will be there, each frame corresponding to a function invocation. This, whenever it calls, that's one invocation that gets inside that one frame. Okay. Third point, at all times computer works on executing whichever function is at the stack stop. Okay, but when there is a function invocation, the computer creates a new frame. Then imagine how many frames are created. Keep thinking. Next slide, I'll show you diagrammatically. And places it at the top of a stack. Okay. Fourth, when the function at the stack stop returns, the computer removes that function's frame from that stack stop and resume its work on the function. Now, on the frame stop, this point these 2 points, this third and fourth, you'll clearly understand when I show you diagrammatically only. I hope these two you understood. Let's see pictorially here. So this is the code, we already discussed the code. Okay, how does the computer work now? Let's see. Step 1, we know this is not the first line of the execution. Okay, whenever it sees the def, it skips, and this is the first line of the code. Okay, this is a line 8. Okay, so in the line 8, this is line 7, this is line 8. In the line 8, there is a function call. I'm going to call the compute function by passing 4. Yes, 4 is stored in the last. I'm going to pass 4. Okay, so this is a stack. Okay, each rectangle, small rectangle, is one frame. So this point, what does this say? The computer creates new frame and places it atop the stack. Is it placing? Yes. Now whenever there is a function invocation, it's going to create a frame. Yes, it created and it placed that frame. Yes, this is step 1 done. In step 2, what's happening? Fifth line, which is your fifth line, by the way? Yeah, this one. 1, 2, 3, 4, 5. Yeah, this one. So when it comes over here, because num is 4, it's going to skip the statement. It's come over here. It's going to return 4 plus, and again this is a direct recursion function, recursive function. Yes. So 4 minus 1, compute 3. So it's again calling itself. Isn't it new frame has to be created by the computer? Yes. So that frame is getting added into the stack. So this goes down. The first, step 1 goes down. The step 2, the latest one, comes to the top. That is, return 4 plus compute 3. Whenever, is it satisfying this condition? Yes. So, but when there is a function invocation, the computer is creating a new frame and placing it at the top of the stack. Yes. Now, third step. Okay, again. So compute 3. 3 is not equal to 1. Comes over here. Okay. Now the new frame is called y, because again we are calling over here. Yes, that is, it's returning 3 plus compute 2. It's placed, new frame is created and it is placed at the top. Step 4. Okay, now compute, what are we passing through? 2. Okay, 2 is not equal to 1. It comes over here. It is going to return 2 plus 2 minus 1, that's 1 over here. Yes, so all other step 1, 2, 3 are at the bottom, and the latest is getting added at the top. Now step 5, this compute 1 is again going to invoke this function. Now it satisfies the base case. Yes, 1 is equal to 1. Right, we attended. This is not a runtime error. It is a good recursive function. Now return 1. Yes, so what happens whenever we are returning? Your fourth point you have to recollect from this slide. What is happening whenever you are returning? Listen to this point. Okay, it returns over here. Okay, after returning, so that's a fifth point. Okay, so return 1, the 1 comes over here. Okay, let's go to the sixth step. So when it reaches over here, it returns 3, yes, to this function. Are you clear why it is returning 3? 2 plus 1, 3. Okay, in 7th, see, is it satisfying? As it returning, it will remove the frame from the stack. Is it satisfying this function? So third point will tell you, as it invoking a function, it gets added into the stack. The fourth point tell you, as it is returning, it removes that function's frame from the stack top. Yes, I think now you understood this, all 4 points. 1, 2, 3, 4. Yes, I will see. Yes, 3 plus 3, 6 is your 7th. So 6 is written towards here. And in 8th point, okay, 4 plus 6, that's 6, the 6 which is returned, right, which is 10, it is returned over here. Now sum, sum is stored 10, and 9 and 10, it's step 9 and 10, it's over here. Your sum, step 9, 10 is assigned to the S sum. Now it gets 10th step, it's getting printed over here. Are you clear? So what does it say? It is mandatory, we can conclude this, it is mandatory to have a base case in order to write a sensible recursion code. Very, very important. Now the program ends and its frame is also removed from the stack, and stack becomes empty. It's going to be removed, print, and this will be empty. Hence compute 4 was executed like this. 4 plus compute 3, yes, 4 plus 3 plus, it's like this, 4 plus 3 plus 2 plus 1. Finally we got the answer. This is how recursive function is handled by the computer. Now at this point I will give you 2 scenarios. Actually this is a program which prints the string backwards. It's a homework for you. Both the programs does the same operation. Okay, both the programs, when you give, let's say, input news, it's going to give you SWEN only, but the logic is little different. I want you to draw diagrammatically all the steps this way. Okay, frame by frame. What happened when a function is called? What happened when a function is function is returning? I want you to draw for both the programs. This is your homework. Okay, we will wind up this video with the last thing, that is, what happens if a recursive method never reaches a base case. Okay, yes, there could be some problem, that is, the stack will never stop growing. Yes, it keeps on growing. The computer, however, limits the stack to a particular height so that no program eats up too much memory. If a program stack exceeds this size, the computer initiates an exception which typically would crash the program. This exception is called maximum recursion limit exceeded. Yes. Thank you for watching. I hope you understood the how to write the recursive function. The next video also we will discuss a lot of other examples like GCD, Fibonacci series, binary search using recursive functions. Thank you all. Bye.